Hi and hello dear friends, welcome back once again to our channel VAAGAI Academy of Mathematics, and this playlist is where you can find video lessons for CBSE Class 7 Applied Mathematics. So following the previous exercises, we are about to take problems from exercise 6.6 for this session from our standard book ML Aggarwal and Neeraj Raj Jain. And again, this exercise is going to be under the concept of sequence and series. So yes, here is what we are going to solve problems. Yes, fine. And this is going to be under the concept of geometric mean. Already in our previous two exercises, we dealt with the problems that are based on geometric progression, nth term, sum of n terms, everything we saw there. And this exercise, it is going to be based on the concept of geometric mean. Okay, fine, yes. And here we have got lots of basics to be seen. So we definitely need to spend some time on these basics. Only then we'll be able to solve problems from this exercise. Though you have very less number of problems in this exercise, we have got some sharp, very crisp basics to be seen. So it is better if we spend some time on these basics. Okay, fine, yes. Yeah, okay. We'll just start with few examples here. Okay, fine, yes. I hope you remember about arithmetic mean. Okay, yes, fine. So we saw problems based on arithmetic mean. Once we completed arithmetic progression questions, we saw about arithmetic mean. Same way, here we are completing geometric progression, then we are entering into geometric mean. That's it. Okay, fine. Okay. So let us start with some basic examples. As I told, we'll just try to insert some geometric means. Okay, the questions will be based on inserting geometric means. Okay, how will be the question? We have some examples here. Now take this first example. Okay, take this first example. Insert two geometric means between 4 and 500. Listen to this question carefully. Insert two geometric means. What do you mean by this geometric mean? That is what we are going to see now. Okay, all right. Geometric mean, in short, we'll call it to be GM. Fine, okay. Let me just note it here itself. It is called GM in short. Like how we call arithmetic mean as AM, geometric mean we'll call it to be GM. That's it. Okay. Now what we have to do here? Here we have to insert two GMs. Okay, two GMs we have to insert. Between which two numbers? Between 4 and 500. And that is the reason I made some two empty slots here. These two slots are going to be filled by those two geometric means. Fine, okay. And how should be those numbers? The numbers by which you are going to fill these two slots here, right? Once after filling this, now the sequence of these four numbers should form a geometric progression. That is what is the meaning of this geometric mean. Let me repeat. The numbers by which you are going to fill these two slots, so that what happens is this entire sequence will become a geometric progression. That's it. Very simple idea. Okay. So you just happen to get a geometric progression. In such a way, you have to fill these two numbers. This is what is your question. Okay, fine, yes. So let us try to solve this question first of all. Technically, with the help of the previous exercise methods and concepts, let's try to solve this question. Okay, fine, all right, yes. So what I'm going to do is, I'm going to take these two values. Okay, let me take these values as G1 and G2. Fine, okay. I'm going to call the two geometric mean values as G1 and G2. So now what is going to happen is, by definition, as I told, these four numbers, which four numbers? 4, G1, G2 and 500. These four numbers will now form a geometric progression. They will form a GP. That's it. Or you can treat them to be the four terms of a GP. That's it. Very simple. Fine. Okay. All right. So in that case, we have to find the values of this G1 and G2. Shall we see how we are going to solve it? Yes. Ready? Yeah. Fine. As usual, we will start from this 4. Now, as per our views, this 4 is going to be the first term of our GP. Is it or not? In that case, we will take A is equal to 4. See, friends, I am just working out all these calculations with respect to this first example only. Fine, okay. Let us just work the first example. We will just try to get the clue from there. Then we will apply it to the other examples. This is going to be the flow. This is what we are going to do now. Okay, all right, yes. Yeah, coming here, we will take the first term to be 4. A is 4. Okay, yes, because first term we take it to be A only, right? So A value is 4. And now what will happen? This G1 will become what? Can I just tell what will be this G1? G1 will be nothing but what? This will be nothing but AR. Is it or not? That is 4R. where R is the common ratio. Because by definition of a GP, what happens? You will just multiply that R to each term to get the next term. This is what is a GP, correct? So my first term is 4. So my second term is what is G1? This G1 is going to be what? A value 4 into R. That's it. And next is what? G2. G2 will be what? G1, which is 4R, that should be once again multiplied by R. I hope I can understand this, right? So this 4 is multiplied by R, we get this 4R. Now this 4R should be once again multiplied by R. Okay, so what we will get? We will be getting 4R square. This is what is G2. Fine, okay? And we completed the first 3 terms. Now come to the 4th term, and that is the last term here. What is the last term? Last term is 500. And how should be that 500 expressed? Can you just tell? This is 4, this is 4R, this is 4R square, and what next will come? Obviously you will get this 4R square should be multiplied by R once again. You will get 4R cube, and that 4R cube is what is equal to this 500. Is it clear? Since these terms form a GP, we are just organizing the terms like this. We are equating this 4R cube is equal to 500. This is what we are getting. So now it is very easy for us to solve the value of R. Shall we solve for R? What we will get? Because we got an equation now which is in terms of R. Now we can solve for R. It is possible, right? So how we can solve for R? 4R cube is equal to 500. So that means R cube is equal to 500 divided by 4. That will be 125. Is it or not? Because you divide 500 by 4, you get 125. That's what I am writing here. So R cube equal to 125. So that means R is equal to simple 5. Because this 125 is nothing but cube of 5 cube. So R cube is equal to 5 cube. That means R is equal to 5. Okay, fine. So we got the value of R. That's it, over. Now this is enough for us to tell the values of G1 and G2. Is it or not? Because G1 we know it is equal to 4R. So this will be equal to 4 into R is 5. 4 5s are, this will be 20. So I can put here as here G1 as 20. And next is G2. G2 is expressed as 4R square. So 4R square will be nothing 4 into 5 square, which is going to be what? 4 into 5 square will be 4 into 25, which means 100. So that means G2 value will be 100. So this will be 100. Now you can check these 4 terms whether they are in a GP or not. Definitely they will be in a GP. Shall we check it? My first term is 4. This 4 into 5 is what is this 20. 20 into 5 is what is this 100. And 100 into 5 is what is this 500. So that means successfully we got these 4 terms to be in a GP with first term as 4 and common ratio is 5. That's it. Okay, is it clear? Fine. I hope the idea is now clear, and I think now you are clear about what is geometric mean and how to find it. Next we are going to do something which is even more interesting, and it is going to be quite important also, and this is going to be little bit maybe confusing also, but still you have to be very sure about this basic. So yes, I'll try to present it in a best way possible. Okay, yes, yeah, fine. So now we are going to generalize this process. Okay, all right. We worked out one example. Now we'll have to try to generalize this process, for which what I'm going to do is I'm going to show you how we are going to insert geometric means between two fixed values. Okay, all right. Yes. Now what I'm going to do is I'm going to take two values A and B, and between these two values we are going to insert n geometric means. Fine, okay. We are going to generalize this. If there are A and B two values, they are the two extremes. Between them we have to insert n geometric means. How we can do that is what we are going to see now. Ready? Okay with that? Yes. Yeah, we'll proceed to this. So first, as usual, what we can do is we have to treat this as a GP. Yes, okay. And yes, point number 2 next is just think of totally how many terms are here starting from A till B. That we have to think. Totally how many terms are there? There are totally A and n terms and then B. That means there are n plus 2 terms totally there. I hope you are able to accept this. Fine. Okay. Yes. I hope it is clear to you, right? Yes. So there are totally n plus 2 terms here available in this geometric progression, and the first among them is what? Which term it is? This is what is A. Okay. Let me write it and show you. There are totally n plus 2 terms. I hope you can understand why it is n plus 2 terms. Why? Because it is starting from A and ending with B. They themselves are 2 terms, and in between them you have got n terms. So it takes a total of n plus 2 terms totally. This is what I come to say. Okay? Yes? Yeah. Now total n plus 2 terms. First term among them is what? Which is the first term? A is the first term. Okay? So that means T1, that is term 1, is going to be A. And what can I tell about this B? This B will be the last term. That is, this B will be the, which term? This will be the n plus 2th term of this GP, which is going to be B. Yes, okay, this is why I told this will be little bit critical for you to understand, but still it is very important for you to take this basic. That's the reason we are spending some time on it. Okay, fine, yes. Yeah, just try to be legible. Just be slow. Okay, yes, slow in your process. Maintain a slow pace, then only you will be able to take it. Okay, yes, fine. So our first term of our GP is A, and last term, that is n plus 2th term of our GP is B. This is what we have. Fine, okay. And we very well know the formula for the nth term. What is the nth term of a GP? It is going to be AR power n minus 1. Is it or not? So that means, how can we express this B? This B being n plus 2th term, this will be nothing but what? This will be nothing but AR power n plus 2 minus 1. I hope I am not confusing you. AR power n minus 1, that is the general formula. But here, since we are equating this to n plus 2th term, this is n plus 2 minus 1. This is what I come to say. So in that case, this on simplification, what happens? You will be having AR power n plus 1 is equal to B. Is it or not? I can equate this. I am just trying to get a relation between A and B. That's it. That is what I am trying. Okay, overall, that's what I am trying here. Fine, okay. This is my first term is A, and R is the common ratio. And since there are n plus 2 terms, n plus 2 minus 1. This is what I am trying to do here. Fine, okay, all right. Now, yes, next point number 2. We have to worry about the value of R. R we have to find. Shall we find the value of R? R, how we can find? Basically, we will try to find the value of R power n plus 1 first. Okay, we will have to find R power n plus 1. This will be equal to, this is B divided by this A comes here. This will be the value of R power n plus 1. And what next we can do is, now we can find the value of R. R will be nothing but what? R is equal to B by A to the power 1 by n plus 1. I hope it is clear to you. This will give you the common ratio. Fine, okay. So all we are worrying to do here is, we are worrying to get the common ratio only. That's it, okay. So once this common ratio is obtained for our geometric progression, we can very easily tell each of the geometric means which are going to come there. Is the point clear? So our objective is to find the common ratio of our GP, and that will give you the values of what are the geometric means. Simple idea. Okay, fine, yes. So the understanding this part is what you may feel little bit complicated. But the thing is, once this process is okay for you, you can easily find the common ratio hereafter for any given terms. Okay, yes, fine. Yeah, so that means what you have here, given any 2 terms A and B, and if at all we want to insert n geometric means between them, what we need? We have the 2 terms anyways. We have the 2 terms, and also we know that there are n terms to be inserted. And we should know the common ratio of the GP. That is what we are finding here. And what is the common ratio? Expressed in terms of A and B. Common ratio R is equal to, just remember this and please note it, B by A to the whole power 1 by n plus 1. Okay, yes. I hope you can understand this part also, yes. Well, because R power n plus 1 is what is B by A. So if you want to find R is equal to, this power goes there as reciprocal. That's why I am putting it here as 1 by n plus 1. Okay, alright, yes. Just kindly note this expression. Why? Because using this expression only we are going to solve the other 2 problems. That's why. Okay, fine, yes. Now shall I apply this rule to solve these 2 problems? Yes, ready? Fine. Yeah, okay. Let me just demonstrate you to get the answer for these 2 questions using this formula. Ready? Yes? Yeah, okay. Now come here. The second example. Here what do we have here? Here we have insert 3 geometric means. Okay, here our question is insert 3 GMs. That means we have to insert 3 GMs here. Between which 2 numbers? Between 10 and 810. This is our question. So we have to insert 3 GMs here. So shall we use this R method? So what will be R? R will be what? R will be equal to B by A whole power 1 by n plus 1. Let us make sure what are the values of A, B and n for our example. What is the value of A here? A is the first value. So, A is equal to 10. B is equal to 810. And what about n? N stands for the number of geometric means we are going to insert. So, that means n is equal to 3. That's it. Very simple. Okay, fine. So, I think I can take this space, some empty space to work out here. Okay, I'll just take this second number, example number 2. Example number 2, I'm going to take there. Okay, let me try finding the value of the common ratio here in this space. Okay, because we need some space to work out, right? That's why. Okay, so common ratio we are going to find for this second problem. Okay, what is common ratio? B by A to the whole power 1 by n plus 1. Shall I substitute the values? So B is what? B is 810. So R is equal to 810 divided by, what is A? A is 10 by 10 whole power 1 by n plus 1. What do we have here? 1 by n plus 1. What is 1 by n plus 1? We know that n is 3. There are 3 terms to be inserted. So that means 1 by n plus 1 is going to be how much? N is 3. So n plus 1 will be 4. So this, when you solve, you can easily get the value of what? You can get the value of R. Okay, fine, yes. So R is equal to, I can cut these two terms. So I will have 81 to the power 1 by 4. And what I can do now is, we need to find the value of 81 power 1 by 4. So what we can do now is, we'll try to express this 81 as a power of 4. I'm sorry, as power 4. Some number raised to power 4. We'll try to do that. We know 1 power 4 is 1, 2 power 4 is how much? It's 16. Try calculating what is 3 power 4. 3 power 4 will be 3 square into 3 square. 9 9s are 81. Simple. So that means this 81 can be written as 3 power 4 the whole power 1 by 4. So that means R is equal to simply 3. That's it. Simple, right? Because 3 power 4 to the whole power 1 by 4 will be 3 power 1. Because I will have 4 into 1 by 4 to be 1. So it's simply 3. That means for our second example GP, the common ratio is going to be 3. That's it. Now we can easily find each of these numbers. How we can find the numbers? First number is 10, right? First term is 10. 10 3s are 30. This is my first mean. 30 into 3. This is 60. Sorry, this will be 90. I'm sorry. Yes, 30 into 3 will be 90, right? I'm sorry. This is 90. Again, 90 into 3 will be 270. And you can check it. 270 into 3 you try to, you can just get this 810. That's it. Very simple. Okay. So that means we are successfully getting the values of the geometric means, the 3 geometric means here. Simple. Okay. So that means no matter how many GMs to be inserted, you take that as n, and these two values as A and B, you will use this formula to find the value of R. Simple. That's it. Okay. That's the process. We have one more example. We'll try to do this example also. Here the question is, insert one geometric mean, 1 GM between 3 and 48. That's it. Okay. Here we are supposed to insert only one geometric mean between these two numbers. Fine. Yes. So that means here A is going to be 3, B is going to be 48, and what is the n? N is going to be simply 1 because there's only one mean to be inserted. So n is going to be 1. Shall I try finding the value of R? Yes. I'll take this as example 3. Okay. I'll take this example 3. So we'll try to find the value of R. R is equal to B by A whole power 1 by n plus 1. So B is 48 divided by, what about A? A is 3 whole power what you will have? Whole power will have 1 by n plus 1. That is 1 by n is 1 here. So you will have 1 by 2. That's it. Okay. That means you will have what? 48 by 3 will be exactly 16. So 16 power half. 16 power half will be simply root 16. Root 16 we know the value is 4. Correct. That means ratio, common ratio for this GP is going to be 4. That's it. Simple. So you can do simply 3 4s are 12, and you can even check it. 12 4s are will be 48. Simple. That's it. So I hope now it is clear to you, right? Yes. Is the point clear? So this is how we find the common ratio for a general inserting of geometric means, and we proceed this way to get the values which are the missing geometric means, which are between any two fixed values. So far we saw about how to insert n geometric means between A and B, and particularly we saw the method how to find the common ratio. So when the common ratio is found, then we can easily find the geometric means, the n geometric means. Fine. Okay. Yes. And this process is going to be very easy when you have a situation to insert only one geometric mean. Fine. Okay. So let us see that. Let us just try to derive it. What if you are asked to find only one geometric mean, okay, given two values a and b, okay, given there are two values a and b, and if you need to insert only one geometric mean between these two numbers, then what we can do here, okay, yes. So let me do something. I will take the geometric mean as g. Okay, so that is the one geometric mean is there. There's only one geometric mean between a and b. I'm going to express that as g. Okay, so shall we see how this can work? Yes, how this is going to work out is okay. So that means here there are only three terms for this geometric progression, and these three terms are going to be in a GP. And we know in a GP the common ratio is going to be same, correct? Okay, so in that case I can divide this second term by first term. Okay, just be careful. I can divide second term by first term, that is g by a. This will be same as third term by second term, that is b by g. You can accept it, this? Yes, this is acceptable, right? You can clearly accept this. Why? Because g by a also will give you the common ratio, b by g also will give you the common ratio of this GP only. So in that case, these two ratios are going to be same. So I will have a relation g by a equal to b by g. That means now I can just cross multiply. If you cross multiply, what happens? You will have g into g. G square is equal to ab. This is what you will have. And this will in turn give you what? G is equal to square root of ab. So that means if at all you have a situation to insert only one geometric mean between any two values a and b, distinct values, what you can do here? We can simply find the square root of AB, the product of those two values. Okay, shall we check it whether it is going to work out here? Because this third example we had a similar situation only, correct? Here we have only two values. I mean, like we need to insert only one geometric mean between these two values, correct? Okay, so here our A is 3 and B is 48. Just try applying this formula. What we get here? G is equal to root of AB, that is root of 3 into 48. Shall I just try checking it? Okay, I'll just show it to, just work it out here. I'll just show it here. So this will be G is equal to root of 3 into 48. So what is 3 into 48? This will be 144. So root 144, we very well know the value is going to be 12. So that means the geometric mean is going to be 12. So that is why I told you, if you have a situation to insert only one geometric mean between two values a and b, you can use this formula. G is equal to square root of AB. You can use this. Okay, fine, yes. And finally, last and very important thing is, we are now about to compare arithmetic mean and geometric mean. That is, what's the relation between AM and GM. Yes, okay. For any two given values, we have the arithmetic mean of the two values and we have the geometric mean of the two values. Now, what is the relation between the two values, or how they can be compared? What is the comparison between those two values? That is what we are going to see now. Ready? Yes, okay. This is the last part. Yes, we will see this one. So, yes, okay, fine. Now, what we can do here is, I will take two values a and b. A and b. I am going to find the arithmetic mean. Okay, let me take the arithmetic mean as a. I hope you remember what we have to do to find the arithmetic mean of two values. Arithmetic mean is nothing but the average that we have seen there itself, right? If you have missed those exercises, please see that there. Okay, I think exercise 6.3, we worked out problems which are based on arithmetic mean. Okay, you can see there. Okay, so for these two values a and b, how to find arithmetic mean? It is going to be, I am expressing it as a. Okay, this is going to be a plus b by 2. And what is the geometric mean? I will take it to be g, and g just now we found it. What is geometric mean? It is going to be root of ab. Fine. Okay, yes, yeah, okay. Now what I am going to do is, I am going to find what is the value of a minus d. Okay, I am going to work out, manipulate a minus d is equal to, just take these two expressions. We will have what? A plus b by 2 minus root ab. This is what we will have, right? Yes, okay, yeah. Proceed. So we will have what? A plus b minus 2 root of ab whole divided by 2. I am just taking this 2 to be LCM. So we will have 2 root of ab whole divided by 2. Okay, fine, yes. Now I am going to just rewrite this same step in a different way. Okay, look carefully how I am going to express this. This a I am going to write as root a square. Okay, then this expression I am going to write as 2 root a root b, and this plus b I am going to write as plus root b the whole square whole divided by 2. I hope you can understand this. Okay, so this a I am writing like this, this b I am writing like this, this 2 root ab I am writing like this. Why? Because now I can clearly see this format. What is this? This is like a square minus 2ab plus b square. But in the place of a, you have root a. In the place of b, you have root b. That's it. Okay. So that means this can be written as what? This will be nothing but this is equal to root a minus root b the whole square divided by 2. Whole divided by 2. And what can I tell about this? Definitely the answer for this expression, okay, when you take a and b to be two distinct real numbers, what happens? Two real numbers basically, okay, two real numbers basically, what happens? Definitely the value of this expression is going to be always greater than or equal to 0. Why? Because the reason is very simple. See the numerator part, this is what? This root of a minus b the whole square, root of a minus root of b the whole square. Whenever you get a value, a real number, if you square it, definitely the answer cannot be negative. It is going to be a non-negative value only. It can be either 0 or greater than 0. That's the reason I'm just placing it as, I'm just taking it as greater than or equal to 0. So from this what you can understand is always a minus g, that is the difference between arithmetic mean and geometric mean, provided the arithmetic mean is the greater value and geometric mean is the lesser value. Okay, so this minus this, it is always greater than or equal to 0, or this would imply what? This would imply what? A minus g is greater than or equal to 0. This will imply what? This implies a is always greater than or equal to g. Okay, fine, yes. So this is what we would imply here. So this condition is also very, very important for us to work the problems which are based on AM and GM. Okay, fine, yes. Yeah, okay. So I hope all the basics are over. All the required things we have seen are over, and there are sub cases also, but we need not complicate the things. Okay, while doing the problems we can go along with those concepts. Okay, but these are going to be very important things. Please do note all these things whatever we have seen so far, and I think this is a right time for us to get into the problems. Start from the first question. Here we have insert. We got two subdivisions. Let's work them one by one. The first subdivision is 3 geometric means between 1 and 256. So we have to insert 3 geometric means between 1 and 256. So that means we will have 1, slot 1, slot 2, slot 3, then 256. So that means these 3 slots are going to be filled by 3 geometric means. Those 3 geometric means are what we have to find. Okay, fine, yes, okay. So let us be sure with the values of a, b and n here. So what is a? A is going to be 1, okay, because a is the first term, so it's going to be 1, and b is the last term, so b is 256. And what about n value? N here is going to be, how many geometric means we are going to insert here? We are going to insert 3 geometric means, so n is equal to 3 here. So that means we can very well use this formula to find the common ratio, is it or not? So if you want to insert n geometric means between a and b, so what is the common ratio? Common ratio R is going to be, so let me work it out in a separate way. Okay, R is going to be what? It's going to be equal to B by A, that is 256 divided by 1, the whole power, what we have to do? 1 by, so 1 by n plus 1. Here our value of n is going to be 3, so that means 3 plus 1 is 4, that's it. So 256 by 1 whole power 1 by 4, this is what we have. So that means this will be equal to simply 256 by 1 is going to be 256 only. And what can I tell about 256? This 256 you have to express as a force for power 4. Okay, power 4 we have to take. Why? Because we have power 1 by 4 here, right? That's the reason. Okay, fine. Yes. Yeah, okay. Let's do something here. We know 256 by 1 is 256. I'm going to rewrite this 256 as, first of all, 16 square, because we know 16 square is 256, right? Okay, 16 square power 1 by 4. And once again, this 16 I'm going to rewrite as 4 square. Okay, so 4 square and then square and then whole power 1 by 4. I hope now you can understand the point, because now what will happen is you will have power of power of power. What will happen? Now we can multiply all the powers. So you will have only 4 power 1, which is going to be 4. Is it clear? Yes. Why? Because 4 power 2 into 2 into 1 by 4. What is 2 into 2 into 1 by 4? That's going to be 1. That means 4 power 1 is 4. So common ratio of this GP generator is going to be 4. That's it. Okay. I think this is enough for us to tell what are the geometric means, right? So let us have these geometric means to be G1, G2 and G3. So let's find their values one by one. So what is G1? G1 is going to be what? G1 is going to be 1 into 4, right? So 1 into 4 is 4, because first term is 1. With that we have to multiply the common ratio. So 1 into 4, I can even write it in a detailed way. Okay, 1 into 4, this is going to be 4. And what about G2? G2 will be nothing but G1. G1 already we got 4. So 4 into this 4, which is going to be 16. And what about last one, G3? G3 is going to be what? This G2, 16 into 4. So we'll have 64. So that means these are going to be the three geometric means between 1 and 256. So G1 is 4, G2 is 16, G3 is 64. These are going to be the answers for your subdivision number 1. That's it. Okay. Yeah, fine. Coming to the second subdivision, here again we have a very similar question. Here the question is insert 4 geometric means between 4 by 9 and 27 by 8. So here we should be careful. We have to insert 4 geometric means between those two values, and that too we have them to be fractions. Correct? Yes. No matter what it is, we'll just put the slots. Okay. So 4 by 9 is there. Then we will have four geometric means. Okay. That means we'll put 4 slots. 1, 2, 3, 4, and then comes this 27 by 8. I hope it is clear to you. So between this 4 by 9 and 27 by 8, we have to insert 4 geometric means. Again, we'll consider them to be G1, G2, G3 and G4. Okay, alright, yes. Okay, fine, yes. What next we can do? Again, as usual, we will try to find the value of R first, common ratio. Once common ratio is found, we can tell all these values, each of these values one by one we can easily tell. Okay, so what is G1, G2, G3, G4, everything we can tell in an order. Yes, okay. Yeah, we'll go for finding the value of R first. So what will be R? R is equal to, again, we are going to use the same formula, B by A, okay. B by A, okay. And we have to be sure about the values of A, B and N also here. What is the value of A here? A is going to be what? A is going to be the first term, 4 by 9. B is going to be the last term, that is 27 by 8. And what about N? N is going to be what? N is going to be the number of geometric means we are going to insert. We are inserting 4 geometric means. So N is equal to 4. That's it. Okay. So N is equal to 4. So now we can use this formula. Okay. Yes. B by A, the whole power 1 by N plus 1 will use. So B by A, first we have to calculate. Okay. So I'll do something. B, first B will come. Okay. B is 27 by 8. Okay. 27 by 8 divided by A will come. Correct. Divided by 4 by 9 will come. So that is what I'm going to do here is, let me just change the division as multiplication sign. So what happens? This A value will be getting reciprocal of that. So it will become 9 by 4. Is it or not? Yes. This becomes 9 by 4. I hope you can understand this, right? So 27 by 8 divided by 4 by 9 is what I'm writing it as 27 by 8 into 9 by 4. That's it. Simple. Okay. The whole power, what will come? The whole power 1 by N plus 1 will come. So which means 1 by, what is the value here? 1 by N plus 1 is what here? N plus 1 is going to be, since N is going to be 4, N plus 1 is going to be 5. So you will have power 1 by 5. This is what you will have here. Correct? Okay. Yes. So this will be equal to, now come here. So we have to express the values. Okay. Just see what I'm going to do here. Okay. Just carefully see here. We have power 1 by 5. Okay. Yes. So in such a way, I'm going to modify the terms which I have inside these brackets. Look carefully what I'm going to do. I'm going to write the numerator and denominator. I'm just going to rewrite them. Okay. Just be careful how I'm doing this. So this 27 I'm going to write as 3 cube divided by this 8 will be 2 cube multiplied by this 9 I'm going to write as 3 square by 4 I'm going to write as 2 square. Okay. The whole power 1 by 5. This way it comes. And what next I can do? I can do it like 3 cube into 3 square. This becomes 3 power 5. Is it or not? Why? Because 3 power 3 into 3 power 2, they both will be getting multiplied, numerator with numerator. So what happens? This becomes 3 power. The powers will be getting added. 3 plus 2. That's what is this 5. Similarly, divided by, here denominator we have 2 power 3 into 2 power 2. That will also, the power, there also the powers get added. Here also we'll get 2 power 5. The whole power 1 by 5. This is what we'll get. So now what will happen? You can once again write as 3 by 2, the whole power 5, again the whole power 1 by 5. I hope you can understand what we are doing here. So I'm just taking this power 5 and power 5 as common. I'm just taking it as a common power 5. And now what happens? 3 by 2, the whole power 5. Once again whole power 1 by 5. Now I can multiply the power. When you have power of power, you can multiply that. So it will get cancelled. You will be left with only 3 by 2 the power 1, which is nothing but 3 by 2. Simple. That's it. So that means common ratio of this GP what we have generated here is going to be what? It is going to be 3 by 2. Once that is found, very easily we can find each of these values. Yes, ready? Shall we find them one by one? Yes. Okay, first we'll start with G1. G1 means from where we have to start? We have to take this 4 by 9. Okay, this is the A value, right? That's the first term of our GP, right? So start from there. 4 by 9 multiplied by what we have to do? 3 by 2 we have to do. So shall we do this? What will come? So this will be equal to how much? So I can cut this 3 and 9 3 times, 2 and 4 this 2 times. So you will have 2 by 3. G1 is equal to 2 by 3. Next, what is come? What is the next term? G2 will be this 2 by 3 multiplied by R value. R value is 3 by 2. Okay. Once you got the terms, you have to repeatedly multiply by R. That's it. Okay. That's the purpose of finding the common ratio itself, right? Yes. The terms are going to be successfully multiplied by the common ratio. That is the reason we are finding the value of R first. Fine. Okay. Yes. Yeah. Okay. This will be equal to, this is simple, right? 2 and 2, 3 and 3. They will be cancelled. So we will have 1. So G2 value is 1. And next G3 will be what? G2, 1 into again this 3 by 2. So 1 into 3 by 2 is simply 3 by 2. And finally, last one, G4 will be this 3 by 2 multiplied with this R 3 by 2, which gives 3 3s are 9, 2 2s are 4, 9 by 4. So that means these are going to be the values of your geometric means. So let's see the values. G1 is 2 by 3, G2 is 1, G3 is 3 by 2, and G4 is 9 by 4. These are going to be the 4 geometric means between which two values? 4 by 9 and 27 by 8. I hope both the prompts are very clear to you. Okay, yes. So here we are asked to find 3 geometric means, here 4 geometric means. First thing, we are finding out the ratio, common ratio of our GP. Okay, how we are finding? Using this formula we are finding. So for which we should be sure about what is A, what is B, and what is N. Once that is clear, we have to simplify this to find the value of R. Then once R is found, we can easily find the values of the geometric means one by one. Okay, that is what we are, the same technique is what we are using for both these problems. Okay, yes, I hope it is clear to you. Yes, now let us move on to question number 2. The second question here we have, if the fourth term of a GP is 2. Okay, so that's a GP whose fourth term is 2. This is what is there given here. Okay, so we'll note it. Okay, term 4 is equal to what? Term 4 is equal to 2. Okay, we'll note it. Fine. Okay, then what is the product of the first 7 terms of this GP? This is what we are asked to find. Okay, all right. Yes, so that means there are 7 terms there, and out of which we have the information about only what is the fourth term. The fourth term alone, it is equal to 2. That's all is given. Okay, so there are 7 terms here. 1 2 3 4 5 6 7. Okay, of course there are many properties to solve this problem. Okay, there are few properties. If you know those properties, it will be very easy to solve this problem, but still it needs some kind of derivation and convincing part. So let us try to make the problem in a theoretical way so as to not confuse. Fine. Okay, yes. Okay, so that means these are going to be the 7 terms of the GP. Okay, and what I'm going to do is I'm going to assume the fourth term as A. Okay, 1 2 3 4. Let us have the fourth term as A. Fine. Okay, this will be very much easy for us to understand also. That's why. Okay, so term 4 is equal to 2, and I'm going to take term 4 as A. Okay, yes, fine. Okay, yes. Now we will have the common ratio of that GP to be R. Fine. Okay, in that case, this will tell you what are the other terms of this GP. Okay, fine. Yes. How, if you ask, it is very easy for us to represent the other terms. How we can represent is, I know this fourth term is A, correct? If the common ratio is going to be R, then what will happen? The next fifth term will be A into R. Sixth term will be AR square, and seventh term will be AR cube. Is it or not? Simple, right? Yes. Okay, fine. All right. And the same way, now we'll come here. The reverse process. Okay, I mean the first 3 terms are missing, right? That part we have to think about that also, right? So we'll think about these terms. We'll come in the reverse order. Okay, I know again start from the fourth term. Okay, I know it is fourth term is A. That means my third term will be what? A by R. Is it or not? You have to divide it back, correct? So A by R, and this second term will be A by R square, and first term will be A by R cube. I think this is easy for you to understand. Like here we are multiplying with R to get the next terms, and here we have to divide by R to get the previous terms. This is going to be our task. Okay, and if you remember, we have worked out a similar problems involving 3 terms of a GP in the previous exercises itself. Okay, I think exercise 6.4, 6.5 there, 6.4 particularly, there we happened to get a similar problem. There we had only 3 terms. How we assumed the terms there? So A, AR, A by R, that way we assumed. Here we have got 7 terms, so we are going in the forward direction as well as reverse direction. But for forward we are multiplying by R, reverse direction we are dividing by R. That's the only difference. Fine. Okay, all right. Okay, yes. And what is our question asking? Then what is the product of these 7 terms of this GP? This is your question, right? Very simple. We have to get the product of these 7 numbers only. That's it. Okay. Shall we see what is the product? Okay, the product is going to be the product of the first 7 terms. This product is equal to, shall we see what is the product? A by r cube multiplied by a by r square multiplied by a by r into a into ar square into ar cube. That's it. Finished. Is it clear? Now what I can do now is I can cut the numerator and denominator same terms. For example, I can cut this r cube and r cube. Here I have r square. Here I have r and r. They are cut. Now you are only left with a terms. See how many a's are there? 1, 2, 3, 4, 5, 6, 7. That is a is multiplied by itself 7 times. So that means a power 7 is going to be the product. And we very well know what is the value of a. A is what, as per our assumption, it is the 4th term, which is going to be 2. So that means our answer will be 2 power 7 is going to be the answer. Simple. Okay. So 2 power 7, if you want to expand, you can expand it. Okay. It's not going to be a very big value. So 2 power 5 is 32, 2 power 6 64, 2 power 7 will be 128. So 128 is going to be the answer for our question number 2. A very simple question. So instead of going by property, we are just going by the assumption of the terms. This looks most acceptable, and also this will be more easy to understand also. That's the reason we are taking this method to solve the problem. Okay, alright. I hope it is clear to you. Only the thing is you have to assume the terms. Once this is done properly, this is done in a proper way, you can easily frame and then get the answer. Okay, yes. So anyways, answer for your question number 2 is 128 is the answer. Next we have question number 3. This is very similar to question number 2. We'll see the question. If the 4th term of a GP is 8 and the 5th term is 16. Okay, so note down, we have got 2 things given in the question. One is there is a GP whose 4th term is going to be what? This is going to be 8, and 5th term T5, this is going to be 16. Okay, T4 is 8 and T5 is 16. Okay, all right. Then the question is, what is the product of the first 8 terms? So if you see the previous question, we had the question asking for the product of the 7 terms. Here we have the product of 8 terms. This is the question. Okay, yes, fine. Okay, so we'll have the 8 terms in order: 1, 2, 3, 4, 5, 6, 7, 8. Okay, this way we will just assume. Okay, and we will even take the terms. Okay, this is term 1, this is term 2, term 3, term 4, term 5, term 6, term 7, term 8. We'll have it like this. Okay, and this time, since we are given term 4 and term 5, let us do something here. Okay, let us do something. Here we will assume term 4 as A, and what will happen to term 5? Obviously, term 5 will become AR. That's it, very simple. Okay, fine. Yes, I hope it is clear to you. So we have term 4 is 8, term 5 is 16. So that means now term 4, as per our assumption, A value is what is 8 and term 5 is AR, it is going to be 16. Now what I can do, I can divide term 5 by term 4. Is it or not? I can divide term 5 by term 4. What happens? If I divide term 5 by term 4, I will have AR by A. That means I will get the value of R. Yes, R will be 16 by 8, which implies R is equal to 2. That's it. Okay, fine. So we have A is equal to 8 and R is equal to 2. That is, A here stands for the 4th term of our GP, and here T5 stands for AR, that is, which is 16, and from that itself we can tell R is equal to 2. Okay, for this GP the common ratio is going to be 2. That's it. Okay, fine. All right. Yes, this is what we are able to find so far. Now, as usual, let us try to find the other missing terms also. Okay, yes. We'll try to fill the forward direction first. So this is A, this is AR. Continue the chain. So T6 will be AR square. T7 will be AR cube. This is AR power 4. Okay, just increase the power one by one. That's it. Why? Because we know the reason is very obvious, that the terms will be multiplied by R and so on. Okay. So to move forward. Okay. And same way to now fill the previous terms. Okay. I mean the first 3 terms. For that, what we have to do, you have to go start from this again term 4, we have to divide by R. Okay, yes. So it means term 3 will become A by R, term 2 will become A by R square, and term 1 will become A by R cube. That's it. Okay. So that means this time what we have to find, we need to find the product of, we have to find the product of the first 8 terms, okay, product of 8 terms. This is nothing but we have to multiply all these terms. That's it. Okay, shall we try to multiply these terms? Okay, and I think here itself we can do, if possible, you can do the cancelling process. Okay, why writing everything once again and then you have to do the process? Maybe if you have to verify it, you can do it. Okay, I'll just try to verify. I'll just try to cancel the terms here itself. Okay, yes, fine. How we can cancel this? See here, anyhow I'm going to multiply all these 8 terms. So for which what I will do is, I will see the numerator, denominator, same terms, I will cancel that. For example, I will cut this r cube, r square, r. That's it. So that means you will be multiplying what terms now? You will have to multiply a, again a. There are how many a's are here? There are 8 a's. So product will be a power 8 into, see here we have r power 4, that r power 4. So the product will be nothing but a power 8 into r power 4. That's it, very simple. Is it or not? Yes, clear? I hope it is clear to you. Fine. Yes, alright. So our product is a power 8 into r power 4. This is going to be the product, but still we have to substitute and then get the answer also, right? We have them in terms of a and r only, and we know the values of a as well as r, correct? Let's substitute them. So a value is going to be 8. So 8 power 8 into r is what? R is 2 power 4. That's it. Fine. Okay. All right. Yes. Now what next I can do? I can still simplify this, right? So I will write this 8 as 2 power 3. Okay. I can write as 2 power 3, right? So 2 cube, 2 power 3, the whole power 8 multiplied by 2 power 4. This is what I will have. So next what I can do is 2 power 3 power 8. Okay. So power of power, what we can do? We can multiply the 2 powers. So I will have 3 8s are 2 power, 3 8s are 24 will come. So 2 power 24 into 2 power 4. So finally our answer will be what? 2 power 24 plus 4, which will be 2 power 28 is going to be the answer. Okay, yes. Again, I just insist one more point. If you are clear with the property, you can directly go for that to get the answer. So with that property, you can theoretically get it. But still, I'm just showing the conventional way to solve the problem. That's it. Okay, fine. So when you assume the terms and then go for it by the basic property of GP, that method is what we are using here to solve the problem. Okay, all right. I hope the method is clear to you. And finally, we are getting the answer as 2 power 28. So that's going to be the answer for our question number 3. Question number 4, we have such an interesting question here. Here we have if A1 and A2 are 2 arithmetic means and G1 and G2 are 2 geometric means between 2 positive numbers A and B. So that is, there are 2 positive numbers A and B. So between that A and B, you are going to insert 2 AMs and you are going to insert 2 GMs. Okay, this is going to be the point. Okay, let's have a note of it. Okay, so A and B are 2 values. You are going to insert 2 AMs. Okay, fine. Okay, and what are those 2 AMs? The 2 AMs are going to be A1 and A2. This is what they come to say. Fine. Okay, all right. Yes. And the same way, between the same 2 values A and B, what you are going to insert is, you are going to insert 2 GMs, geometric means, and they are what are G1 and G2. Okay, G1 and G2. Likewise, you are inserting 2 AMs and 2 GMs between A and B. Okay, fine. Yes. If that is the case, then what is the question? Then find the value of A1 plus A2 whole divided by G1, G2. This is going to be the question. Okay, fine. Yes. And if at all we need to work out this question in a very easy way, we should strongly know some 2 important properties. Now let us see about those properties first. We'll see the properties, then we will use that property to solve this problem. Okay, fine. Yes. Why? Because if you come to use this property here, the way of solving this question is going to be very, very easy. That's the reason. Okay, yes. Okay, fine. Yes. And what is that we need to find here? We need to find the value of A1 plus A2, noted, A1 plus A2 divided by G1, G2. Okay, this is going to be the question whose value is what we have to find. Okay, we will hold this. First, we will come see what properties we have to see here to solve this problem. Okay, fine. All right. Yeah, we have got 2 properties. Okay, they are going to be, the 2 properties are based on, one of them is going to be based on arithmetic means and the other one is going to be based on geometric means. That's it. Okay, fine. Yes. So we'll try to understand these properties in a careful way because they are going to play a very vital role in solving this problem. That's the reason. Okay, yes. Coming to the first one. Okay, coming to the first one. Given there are two values and if you are going to insert n arithmetic means between those two values. Given any two values. Okay, see here we have got two values as a and b. Between a and b only we are inserting arithmetic means. Same way, if you come to insert n arithmetic means between two values a and b, then what happens is the sum of those arithmetic means, the sum of those n arithmetic means, that is if you add all those n arithmetic means, that sum will be equal to what? It will be equal to n times single arithmetic mean, that is between the same two values a and b, if you come to find one single arithmetic mean, okay, one arithmetic mean, you multiply that one arithmetic mean with n, that value will be equal to the sum. This is what they come to say from property 1. Okay, yes, okay, fine, yeah, okay, yes. Now why I am insisting here is, let us try to use this property over here, this problem. Fine, okay, because here also we have a similar situation. What similar situation? We are inserting arithmetic means between our two values a and b. Is it or not? And how many arithmetic means are we inserting here? We are inserting arithmetic means a1 and a2. We are inserting two arithmetic means. So that means based on this first property, what we can tell here is the sum of those n arithmetic means. Here n is what? Here n value is 2. Because we are inserting only two arithmetic means, right? Yes. So in that case, we are inserting two arithmetic means. So the sum of those two arithmetic means, that is simple. What are the arithmetic means? They are a1 and a2. That is this a1 plus a2. The sum of these two arithmetic means will be equal to what they are coming to say? It is equal to, see the right hand side. Right hand side they are coming to say n into, that is 2 into, because n is 2 for us, right? So 2 into the single arithmetic mean between those two values a and b. So what is the single arithmetic mean between a and b? How do we represent it? We know how to represent it, right? We have seen in the introduction part itself, right? How we represent the arithmetic mean of the single arithmetic mean of a and b? It's very simple. You just have it as a plus b by 2. That's it. Because those are two values for us, right? Between them is what we are inserting the arithmetic means, right? So we'll have a1 plus a2. This sum will be equal to 2 times, that is n times of, so 2 times of 2 into the single arithmetic mean of a and b. Single arithmetic mean is what is? We write as a plus b by 2. That's it. Very simple. Okay, fine. All right. Yes, I hope it is clear to you now. This is the first property. And now coming to the second property. Okay, second property, it says something about geometric mean. What is it saying about geometric mean? The product of n geometric means is equal to, that is between the same two values a and b, if you come to insert n geometric means now, then what happens is the product of those geometric means, n geometric means will be equal to, it will be equal to what they are coming to say? This will be equal to the single geometric mean between those two values a and b raised to power n. This is what they are coming to say. Okay, fine, yes. Now let us try to use this property to have the second condition, to have the second relation. Okay, fine, yes. Why? Because here also in our sum between the same two values a and b, we come to insert two geometric means. Is it or not? How many geometric means are we inserting? Here we are inserting two geometric means. Correct? Okay. G1 and G2. That is two geometric means. So as per this condition, this property, n value is going to be how much? Again 2 only. Here we are inserting two arithmetic means, n is 2. Here we are inserting two geometric means, again n is 2 only. Fine. Okay. So what is it they are coming to say? The product of those two geometric means. So what are our geometric means? G1 and G2. So we have to get their product. So product means G1 into G2 is equal to, this is equal to, what they are coming to say? This is equal to the single geometric mean raised to power n. What do you mean by single geometric mean? Single geometric mean between a and b, we know how to represent it. That also we saw in the introduction part itself. What is it? Between a and b, what is the single arithmetic mean? If you have only one, sorry, single geometric mean, single geometric mean. What is the single geometric mean between a and b? We have seen that, right? I told in the last part, okay, how we derived it. When you have a situation to insert only one geometric mean between a and b, what do we do there? We do it like, we will have to take the square root of ab. This is what we saw, correct? Okay, the square root of ab, that's a single geometric mean, raised to what power? Raised to the power n. Here n is again 2, so whole square. This is what we have. I hope it is clear to you, right? So finally we got the expressions for a1 plus a2 is equal to 2 times of a plus b by 2, and g1 into g2 is equal to root of ab the whole square. That's it, okay? And if you come see here, this expression is what we have to find the value. Fine, okay? What is the value? Find the value of a1 plus a2 divided by g1 g2. Okay, fine, yes. And if you see here, by properties we have the values of a1 plus a2 and also g1 g2, because this g1 into g2 is like g1 g2 only, right? So let us substitute these expressions over here. So what happens? We will have 2 into a1 plus a2 will be is equal to 2 into a plus b by 2 whole divided by denominator is g1 g2. g1 g2 is what for us? Square root of ab the whole square. This is what we have. And further we can simplify, right? What we can do here? I can cut this 2 and 2. So you will have what? Numerator you will simply have a plus b divided by, come to the denominator portion, here we have what? Square root of ab the whole square. So root of a value whole square will be simply what? You can cut this square root and square, you will be simply left with ab. So the simplified answer is going to be a plus b divided by ab is going to be the answer for your question number 4. I hope it is clear to you. The only thing is you should be sure with this property, okay? These two properties, okay? One is based on arithmetic means, the other one is based on geometric means, okay? So one is for the sum of n arithmetic means, the other one is for the product of n geometric means. Okay, fine. If you are sure with this, then the way of solving this question is going to be very, very easy, okay? And one more thing is, even without using this property, we will be able to solve the problem. How we solve the problem? We have to insert those arithmetic means, okay? We have to get the values of a1, a2, g1, g2, everything we have to find. Each one we have to find, and then we have to substitute it here to get back to simplify, and everything we have to do. I will not say that it is not possible. It is possible, but of course that's going to be a very huge method for you to solve the problem, okay? Yes. So these are going to be the very easy method using the property. We can solve it, okay? So anyways, the answer for this question is going to be a plus b whole divided by ab is going to be the answer for your question number 4. With us is question number 5. Here our question is, insert 5 geometric means between the numbers 576 and 9, and also show that their product, okay, I mean the product of those 5 geometric means, okay, show that their product is equal to the 5th power of a single geometric mean between the given two numbers. I mean the same two numbers, 576 and 9. Okay, yes. So if you see clearly, we have got two tasks here. Okay, fine, yes. We have got two tasks. What are the two tasks here? One is we have to find the geometric means between 5 geometric means between these two numbers. That is the first task. And second thing is we need to show something else. What is it we have to show? We should show that the product of these 5 GMs is equal to the 5th power of the single GM. Okay, this is what we need to show here. And of course, if I want to say in detail, this is just like we are going to prove that property, okay, using these numbers. The property that we have just seen in the previous question, if you see there, among those two properties, what we have seen there, right? Among those two properties, the second property is what here theoretically we are asked to prove. That's it. With a given example of two numbers. Fine, okay, yes. And if you are able to prove this, it is like a verification of proving that property. Okay, fine, yes, okay, all right, yeah, fine. So yeah, coming here, we have the question to be, insert 5 geometric means between which two numbers? 576 and 9. Okay, yes, let us note those numbers. 576 and 9, between them we have to insert 5 geometric means. So we will put like this, 1, 2, 3, 4, 5. Okay, so let us take those values to be G1, G2, G3, G4 and G5. So these values are going to be the 5 geometric means between 576 and 9. Okay, all right, yes, done. So first of all, let us try to find the values of these 5 geometric means, for which we have to take the help of which formula? Of course, again we have to get back to this common ratio formula. Okay, between A and B, the common ratio, if you want to find the n geometric means, the common ratio is going to be what? Common ratio R is going to be equal to, R is equal to, what we have to do? We have to take it as B by A to the whole power 1 by n plus 1. Okay, yes, this is what we have to use. And of course here what are the values of A and B? A is 576 and B is 9. That's it. It's clear, right? A is the first value and B is the last value. So we have those two values also available here. And of course, what's the value of n? N is going to be 5 because we are inserting 5 geometric means. So n is equal to 5. We can exactly substitute those values here. Shall I do that? Yes. Yeah, okay. So B by A, that is 9 divided by 576 whole to the whole power 1 by n plus 1, that is 1 by n plus 1 is going to be what? N is 5 here, so n plus 1 is going to be 6, so power 1 by 6. This is what we have here. Okay, fine, alright, yes. What next I can do? I can simplify the term what I have inside. So these numbers we can simplify. This is 9 and this is 576, right? So we can cut it, right? So 9 1s are 9 and here 9 6 are 54 and balance is 3. 9 4s are 36. So we have 1 by 64 raised to the power 1 by 6. This is what we have. So this I can once again write it as 1 divided by, we will write this 64 as what? We can write this 64 as 2 power something. Shall we try to write this? Why particular 2 power? The reason is there. Okay, why? Because here I have 1 by 6 as the power. If I want to get as power 6, then what I have to do? That is what I have to think. Okay, yes. Okay, so you can even think like this. This 64 can be basically written as 8 square, correct? It can be written as 8 square, and that 8 again you try to write as a power of 2. It becomes 2 cube. So overall what you can do now, this 64 you can write as 2 power 6. Okay, so 1 by 2 power 6 whole power 1 by 6. So that means now you can simplify and get the value of r as what? R is equal to 1 by 2 power 6 the whole power 1 by 6. That's going to be simply 1 by 2. That's it. Now you can very easily get the values of all these geometric means. Yes, ready? Shall we calculate them one by one? Okay, I'll put a line here. So G1, G2, I'll put them one by one. G3, then we have G4 and then G5. Okay, let's try to find the values one by one. Okay, all right, yes. Yeah, start from G1. So G1 means we have to do from where? We have to start from the A value first of all. Okay, A value is 576. So 576 into R we have to do. R just now we got it 1 by 2. So 576 into 1 by 2. So what will be this value? So 576 into 1 by 2 will give you 288. Correct? Is it correct? You can even check it and see, right? Okay, this will be 576 into 2. This will be 2 times. This is 8 times. This one again 2 8s are 16. 288. Okay, G1 is 288. And what next we have? G2 we have. G2 will be what? G2 will be this G1 288 into 1 by 2. This is what we have to do. So this, if you calculate, you will be getting 144. This is G2 value. Continue the chain. Okay, G3 will be what? 144. G2 value 144 into 1 by 2. Repeatedly you have to do multiply by 1 by 2, 1 by 2, 1 by 2 because R value is 1 by 2. Okay, when you insert this, how many GMs? 5 GMs. Here R value is going to be 1 by 2. Okay, fine. All right. Yeah. Okay. So yeah, we have 1 by 2. So this will be 72. Correct? Because 7 2s are 14 and 7 2 2s are 4. That's why 72. And yes, continue. Next, here we have G4. So G4 will be 72 into 1 by 2. That will give you how much? This will be 72 into 1 by 2 will be 36. This is the value of G4. And last one more. G5 we have to find, so for which I have to do 36 into 1 by 2, that will be 18. Okay, yes, verified. Okay, so we got all these values G1, G2, G3, G4, G5, up to G5 we found it. If you want to verify, you can even verify. From G5 you multiply R once again, that is this 18 into 1 by 2 you just try to do it. What you will get? You will be getting 9, that is what is your last term. Hence verified. Yes, clear? So that means successfully we got all the 5 values of G1, G2, G3, G4, G5, everything we got it. So that means these are going to be the 5 geometric means between which two numbers? Between 576 and 9. Fine, okay. One part is over. Next task. What is the next task? Next we have to find what? Next we have to find the single geometric mean, right? We have to find the single geometric mean between the same two numbers 576 and 9. Okay, this also we have to find, right? Let me put a line here also. Okay, fine. All right, yes. So this also we have to find, right? How do we represent a single geometric mean? Single geometric mean means we will write as G. So how do we write G? Single geometric mean, we know the formula. It's going to be equal to root of AB. Is it or not? This is what we know. So this is equal to, what are our A and B values? A and B values are going to be same. They are the same two extremes. Okay. A is 576 into B is going to be 9. So root of 576 into 9. This is going to be the value of what? This is going to be the value of a, root of ab. Okay, fine, yes, okay. So let's now try to simplify this expression. Shall we do this? Yeah, this will be equal to, okay. So I will try to do some kind of adjustment here. Yes, shall we do it? So let me write like this, okay. 576, I am going to split it, okay. 576 I can split it as, so with 4 tables I try to split, okay. I have a reason, that's why, okay. With 4 tables I will try to split it. So if I try to do it in 4 tables, what happens is this will become 144 into 4, fine. 576 I am writing as 144 into 4, and this into 9 will come, okay, fine, yes. So that means I will be getting root of 144 into this 4 9s will be 36. I'm just splitting here, joining here, that's it, okay. So this is what I will be getting. So this will be equal to, now you can simplify it very easily. What you can do now, root 144, you know it is 12, and this is root 36, this is going to be 6. So 12 6 are, it is going to be 72. So the single geometric mean between a and b, I mean 576 and 9 is going to be what? This is going to be 72. So now you are sure about all the values. All the values you are very sure about it. What all values? We have the two basic values 576 and 9. Between those two values we inserted the 5 geometric means, that is also done. And between the same two values 576 and 9 we inserted that single gem also, that is 72. Both are ready, okay, fine, yes. And now let us move on to the second part of the question. What is the second part of the question? Here we are asked to show what? We have to show that, okay, we have to show that the product of the 5 geometric means, okay, the product of the 5 geometric means is equal to the 5th power of the single geometric mean. This is what we have to show, okay. That is, we have to show that the product of the 5 geometric means, that is G1 into G2 into G3 into G4 into G5, this product is equal to, what we have to show? We have to show that this is equal to the 5th power of the single geometric mean. That is, single geometric mean is G power 5. This is what we have to show. Fine, yes. Shall we prove this? Okay, yes. So yeah, we'll start from the left hand side. LHS is going to be what? LHS is G1 into G2 into G3 into G4 into G5. This is what we have on the left hand side, right? Yes, okay, yes. So this is equal to, now let's just copy down the values, because we know each of these values here are available here itself, right? G1, G2, G3, G4, G5, everything is available. Just substitute those values there, okay? Shall I do that? Yes, we'll do it like this. 288 into, this is 144 into, this is 72 into, this is 36 into, this is 18. Yes, shall I do like this? Fine, done. Okay, yes. Now what next I can do is, I can just format these data something like this. I'll just try to format the data like this, okay. How I can format is, just listen carefully how I'm going to do that, okay. Just listen carefully. This 288 I'm going to do like this, okay. Let me try to express everything as 72s itself. Shall I try doing that? Yes. Okay, I'll express everything as 72 itself, okay. Take this 288, this I'm going to write as 72 into 4. I can do this, right? 72 into 4 will be 288 only, right? Into this 144 can be written as 72 into 2. Then multiplied by this 72 I am writing as 72 itself. Now this 36 I am going to write as 72 divided by 2. And finally this 18 I am going to write as 72 divided by 4. I can do this, right? Yes. Why? Because now it will be very easy for me to cancel the terms. How I can cancel? This into 4 and divided by 4. This into 2 and divided by 2 I can cancel. Now I am left with what? I am left with 72 into 72 into 72 into 72 into 72. That's nothing but 72 to the power 5. And this is what is equal to what? What is our 72? 72 is nothing but the value of geometric mean, the single geometric mean G. So G power 5. So that means we are successfully able to show that your left hand side is equal to G power 5. That's nothing but your right hand side. Okay. So that means we are able to get the values of the 5 geometric means and the single geometric mean between the given two numbers, and also at the same time we are able to show that this product is equal to this value power 5. Okay. Yes, we are able to prove, hence proved. Okay. And this is going to be the solution and proof for this question, question number 5. We have question number 6. Here the question is, the arithmetic mean between two numbers is 34 and the geometric mean is 16. Find the two numbers. This is going to be the question. Okay. The question appears to be very simple. Okay. There are just two things given in the question, the data, and using these two things we have to find the two numbers. Fine. Okay. Yes. and most of the students will try to solve this problem in a complicated way. Let us see some interesting method to solve this problem in a comparatively easier way. Fine. Okay. Yes. Okay. Done. Yeah, we'll proceed for that. Okay. Yes. So yeah, coming to the question, there are two numbers. Okay, there are two numbers. We don't know what are the two numbers. Okay, here there's a number, here another number. Okay, we'll have those two numbers to be A and B. Fine. Okay. All right. Yes. So for this number A and B, you are finding the arithmetic mean. Okay, arithmetic mean of these two numbers will be somewhere between only. Correct. It will be between these two numbers only. Correct. So between A and B, the arithmetic mean is going to be 34. Okay. Fine. Yes. Between these two numbers, the arithmetic mean AM is going to be what is? It is going to be equal to 34. This is what is given. And also between the same two numbers A and B, they are finding the geometric mean. The geometric mean is going to be how much? That is going to be 16. Okay, GM is going to be 16. Okay, so AM of the two numbers A and B is 34 and GM of the same two numbers A and B is 16. Okay, fine. All right. So that means they are finding a single AM and single GM, and we very well know how to represent those two values. Okay, single AM and single GM, we know how to represent those two numbers. Fine. Okay. All right. Yeah, we know them very well. So in that case, what we can try to do here is, we will try to just construct a relation between the two values. Okay, A and B, using this AM as well as GM. We'll try to do that. Okay. Yes. All right. Yeah. Fine. First, coming here to this AM's chapter. Okay, AM, we will have it to be what is? We will have it to be A plus B by 2. This is what is the AM. Correct? Is it or not? So this is what is equal to, what we can tell is, this is equal to 34. Fine, we can tell, right? That is, the AM of A and B is what is equal to 34. And one more thing we have to understand here. What we have to understand here is, since this 34 is the arithmetic mean of A and B, what you can tell is, these three numbers will form an arithmetic progression. We can tell that, right? So A, 34 and B, they all will form an arithmetic progression. Yes. Okay. Fine. Understood. They will form an arithmetic progression. So that means the difference between 34 and A will be same as the difference between B and 34. I repeat it once again. The difference between 34 and A will be same as difference between B and 34. That is, this difference will be same as this difference. The common difference will be the same. Fine. Okay. So in that case, let's try doing something. Okay. Here we'll do a small trick. Okay. So here we'll take the common difference as X. Let's take the common difference as X. It is not going to be much complicated at all. Okay, don't feel it to be much complicated. Let us assume the common difference to be X for this arithmetic progression. Okay, yes, I will even note it here. The common difference of this AP is going to be X. We'll have it like this. Now we will try to represent A and also B in terms of X. We'll do that. Okay, and 34. We'll try to do that. Yes. Fine. Okay. Now what will be A and what will be B? That we will see now. Yes. Ready? Shall we do that? Yes. Now A will be what actually? I know this term is 34. Now from 34, if I want to move to A, what I will do is I will just do 34 minus X. I hope I can understand this. Because A plus X if I do, I will be reaching 34. But from 34, if I want to go to A, what I will do? 34 minus X I will do, I will be reaching this A. Correct? So A will be 34 minus X. And next, coming to B, what will be B? B will be nothing but, here again the common difference will be the same X only, right? So what will be B? B is like moving in the forward direction. From 34 you move to the forward direction. So you will reach 34 plus X. If you do, you will be reaching B. So B will be 34 plus X. Okay, is it clear? So these are the two pieces we are collecting. Okay, fine. Yes, this is from the information what we get from the question. But this construction, we are getting it from the clue by taking it to be an arithmetic progression. That's it. Okay. So that means the new expressions for A is 34 minus X and B is 34 plus X. Fine. Okay. All right. Yes. Okay. So this piece is over. Done. Now coming to this piece. Here what is that they are given? Between the same two values A and B, the geometric mean, the single geometric mean is what? This is equal to 16. We know how to express single geometric mean also. How to express single geometric mean? Single geometric mean means we can take square root of AB. So square root of AB is what is equal to 16. This is what they come to see. So that means square root of AB is 16 in the sense we can write AB is equal to 16 square. 16 square means it's going to be 256. Is it or not? Yes. So this is what we are getting. Fine. Okay. Now we have got three expressions. One is for A, the other one is for B, and here the third expression also we have, which says AB is equal to 256. Now shall we do one thing? We have got A and B expressed in terms of x, right? Let us substitute these two relations here in this expression. Shall we do that? Yes, ready? We'll do that. Okay, we have got more space there. So let me continue it there. Okay, be clear with the thing. We know that A is 34 minus x, B is 34 plus x. How we are getting this? This is from that arithmetic progression concept we are getting these two expressions. And here this one how we are getting? This is from the geometric mean data they are given. From there we are taking this information. Okay, now I am going to substitute these values, these expressions for A and B respectively here in this equation. Okay, what is this equation? AB is equal to 256. This is my equation, right? I will even write it in a fresh way. Okay, AB is equal to 256. This is my equation. Let me substitute A and B here in this equation. Okay, let's see what will happen. Okay, so A into B, that is A is 34 minus x into B is 34 plus x is equal to what? This is what is equal to 256. We'll put it here. Fine. Okay, done. Yes. Now shall we just see this expansion? Yes, shall we expand this? So if you try to just expand it, this is like A minus B into A plus B. So what you will get here is, you will have it to be A square. So 34 square minus B square, which is x square. This is equal to 256. So now what is 34 square? 34 square will be equal to what? 34 square will be equal to, we can calculate it separately. Okay, yes. So 34 into 34, this will be nothing but 4 4s are 16, 1. Next we will have 3 4s are 12, 3 4s are 12. 12 plus 12 is 24. 24 plus 1 is 25. So 5. Again 2 is the carry. So 3 3s are 9 plus 2 is 11. So we will have 1156. Okay, we got 1156. So 1156 minus x square is equal to 256. And now what we can do? Now we can find the value of x square. So x square will be equal to 1156 minus 256. And this is exactly equal to how much? 56 minus 56. This will be 00. 11 minus 2 will be 9. So 900. We are getting x square equal to 900. So that means x is equal to, we will be getting what? Since x square is equal to 900, we will be getting x is equal to, we will have plus or minus. What about square root of 900? Square root of 900 will be, it's exactly how much? It's easy to say, right? Plus or minus. This is easy to say, right? Square root of 900 will be simply 30. So that means we get two values for x. One is x is 30 and the other one is x is minus 30. We are getting two values, and accordingly we will be getting the values for A and B also. Is it or not? Because our question is, we need to find the two numbers A and B only. Those are the two numbers, right? A and B are the two original numbers. Those two values are what we need to find, and here we have the values of A and B. What are A and B? A is equal to 34 minus x and B is equal to 34 plus x, right? So shall we compute the values? Yes, shall we do it? So we know x is equal to 30 or minus 30. First we'll take x as 30 and say, okay, take x as 30 here. Then what happens? A will be 34 minus 30, that will be 4. And B is equal to 34 plus 30, which is equal to 64. These are the values we are getting. Or otherwise, we'll have A and B to be, this time if you take x as minus 30, now you will have what? A is equal to 34 minus of minus 30, that will be 64. Because 34 minus of minus 30 will be 34 plus 30, which is 64, and B will be 34 plus of minus 30, that is 34 minus 30, which is going to be 4. So these are going to be the values of A and B. That is, we are getting the same two numbers. One is 4, the other one is 64, but we are getting in a swapped way. Okay, first case is A is 4, B is 64. Second case A is 64 and B is 4. Okay, but anyways, these are going to be the answers for your question number 6. I hope I can understand this, right? Okay, without going for much complications. Okay, we are just trying to get in a simple terms. Okay, with one variable itself we are trying to get, we solve it, and then from there we get the missing two values. Okay, or otherwise we have to go for big other quadratic equations and then we have to solve it and then get the answer. I'll not say that that is much tougher, but compared to that method it's going to be little easier. That's the thing I just came to say. So anyways, these are going to be the answers for your question number 6. Question number 7. Here we have the AM of two numbers A and B exceeds their GM by 2. Okay, so there are two numbers A and B. Okay, A and B, there are two numbers, and they are just comparing the AM and GM of these two numbers. That's it. Okay, that is what they are comparing in the first statement of this question. How are they comparing it? Let's read it again. The AM of the two numbers A and B, that is the AM of A and B. Okay, let us have the AM of A and B. Okay, let us have the AM to be A and we'll take the GM to be G. Okay, we will express like this. So in this case, what is this A? They are coming to say that this AM is equal to, okay, this AM of the two numbers A and B exceeds their GM. Okay, this is going to exceed the GM. Exceeding the GM means, what is the meaning? This value is going to be, this is more than GM by 2. This is what they are coming to say. That is, this is equal to the GM's value, that is G plus 2. This is what they come to say. Very simple. Okay, all right. Yes, fine. And also we know the expressions for what is A and what is G. That also we know. Okay, because A stands for the single arithmetic mean of A and B, and G stands for the single arithmetic mean between the same numbers A and B. Okay, fine. We know the expressions for A and G also. That also we will handle. Okay, let's see it. But anyways, we'll continue the question. What else is given? We will see. What next is given is the ratio of the two numbers is 4. What do you mean by the ratio of the two numbers? That is, these two numbers they are comparing. Okay, the ratio of the two numbers means these two numbers A and B they are comparing. The ratio of A and B, A divided by B is, this is going to be equal to 4. This is what they are giving here. Okay, so in that case, what are the values of those two numbers? Find the numbers. This is the question. Okay, not a very difficult question and all. It's going to be a very easy question only, because we know the expressions how to deal with these. Once we know that, we can easily solve this. Yes, okay, fine. Yeah, okay, yes. Yeah, coming back here, what we can do is, we know what is A and what is G. Okay, A is the single arithmetic mean of A and B. What is the expression single arithmetic mean means? We can write as A plus B divided by 2. This is equal to, come to the right hand side, this is G. G stands for what? This is equal to root of AB. Okay, yes, plus 2. This is what we have. Fine, okay, all right, yes. So now we got an equation in terms of A and B itself. Now see, there's one more relation here. What is this? What is this relation telling? This relation says A by B is equal to 4. Okay, so shall we do one thing here? We'll try to find what is A in terms of B. Okay, so now A is equal to this B. I can take it to the right hand side, so it becomes 4 into B, so 4B. So now once again, what I will do is, I got this relation and this relation. Let me just substitute this A equal to 4B, this relation, in this equation. Okay, shall we do that? So if you do that, what happens is A equal to 4B. So wherever A comes here, in the place you just try to substitute A is equal to 4B. Shall we do this? Yes, if you try to do so, what happens is, here we have A, that is here itself I can put 4B plus B divided by B is equal to, now right hand side will be what? Here we will have root of, okay, square root of AB, that is 4B into B, okay, plus 2. This is what we'll get. Correct? Yes. Okay, fine, we'll continue. So what next I will have is, here I will have 5B by 2 is equal to, now come here, here we have what? We have 4B into B, that means this is like 4B square. Correct? Yes, root of 4B square. What is root of 4B square? We know root of 4B square will be equal to, root 4 is 2 and root of B square will be B. So simply we will have 2B. Okay, alright, yes. So 2B plus 2, this is what we will be getting. Okay, anyways, we'll continue here. Okay, we'll just continue. Now what happens is, our entire relation is now it is in terms of B only. Correct? Yes. Yeah, fine. So 5B by 2 equal to 2B plus 2. Now I will bring this 2B to the left hand side. Okay, so I will have 5B by 2 minus 2B is equal to 2. This is what I will have. And next what I will have is whole divided by 2. Okay, I'll take the LCM. Okay, if I take LCM, what happens is 5B minus 2 into 2B will be 4B is equal to 2. So I will have B by 2, because 5B minus 4B will be 1B. So 1B, B by 2 will be equal to 2. So B is equal to, this 2 I can take there. 2 2s are, it becomes 4. So successfully we got the value of B. That is, we got one of those two numbers. And with this we can easily find the other number also, because we know the relation, right? A is equal to 4B, right? Now we will once again substitute B equal to 4 in this relation. Okay, so now what you will have? A is equal to, what you will have? You will have A is equal to 4 into B, that is 4 into 4. So you will get the value of A also. A is 4, 4s are 16. So that means we got the two numbers. Successfully we got the two numbers. So what are the two numbers? The values A and B are, what are the two values? They are respectively what? A is 16 and B is 4. These are the two values. Okay, so easily we got the values. Not much to complicate here. If you just know the meaning of what is AM and what is GM, you can easily solve it. Apart from that, everything is going to be equation solving only. If you carefully do it, you can easily solve for the values of A and also B. So the values are 16 and 4 are going to be the answers for question number 7. Next we have question number 8 with us. Another interesting question. If G is the geometric mean between A and B, then show that 1 by G plus A plus 1 by G plus B is equal to 1 by G. This is going to be the question. So here we have to give a proof for this question. Okay, so we have to prove this given statement, and given what G is the geometric mean between A and B. We know what is the single geometric mean. Okay, so G means what? G is the single geometric mean of A and B, between A and B. So that means G can be expressed as what? G is equal to nothing but root of AB. That's it. Okay, so if G is equal to root of AB, then what we have to prove? We have to prove this given statement. Very simple. That's it. Okay, yes. So as usual, let us start from the LHS and we'll try to simplify and we'll try to get the RHS. Okay, this is going to be our objective. So let's start from the LHS. Okay, so LHS is equal to, we'll take the LHS side. Okay, we have 1 by G plus A plus 1 by G plus B. This is what we have. So let's carefully substitute the value of G here. Okay, you know G is what? Root of AB, is it or not? So we'll have 1 by, what we can do here is, we'll just take it to be like root of AB plus A plus 1 by root of AB plus B. Okay, we'll have it like this. Next, what I can do is I will take the LCM. Okay, if I try to take LCM, what happens is we will have to multiply these two numbers. Okay, we have to multiply these two values. So if you multiply, what happens is you will have root of AB plus A multiplied by root of AB plus B. This is what you will get in the denominator portion. And what happens to the numerator? Numerator will be cross multiplied. Okay, so 1 into this value plus 1 into this value. This is what we will get. Okay, so if you do so, what happens is 1 into this value will be root of AB plus B plus, here I will have root of AB plus A. This is what I will have. Yes, clear, done? Okay, fine. Yes. So yeah, okay, I think we have more space there. We'll continue there. Okay, so this will be equal to, this is equal to, what next I can do here is, I will just rearrange the terms. Okay, we'll try to rearrange the terms. So when you try to do so, what happens is, come to the numerator. Numerator will become A. Okay, I'll start from this A plus, next what you have is, you have root AB and root AB. So you have got 2 times of root AB. So you write as 2 root AB plus, here you have B and write as B. Fine. Okay, all right. Yes. Whole divided by. Now come to the denominator. We have to do the product. Here we have to multiply these two terms. Let's carefully multiply the terms. Okay, so if you try to do so, what happens is you will have root AB into root AB, so which will be AB, then plus root AB into B, that is, it will give you B root AB. Okay, I'll just extend this bar. Okay, this is E plus A into root AB, so A root AB plus, once again what you have to do, once again you have to multiply A into B, that will be another AB. I hope you can clearly understand. So numerator, I am just simplifying the terms, I am writing in an order. This is what is giving me this term, and denominator we are multiplying this and this, these two factors we are multiplying, so that we are ending up with the product of 4 terms. This is what is this term. Okay, all right. So this is equal to, what next we can do here is, let us have the numerator as it is. Okay, A plus 2 root AB plus B, we'll have it as it is, whole divided by. Now come to the denominator portion. Okay, come to the denominator portion, be careful. So here what we can do is, here also I am going to rearrange the numbers. Okay, rearrange the values. Okay, how I am going to rearrange is, I am going to write this A root AB. Okay, A root AB. Okay, A root AB plus, here I have AB plus AB, that becomes 2AB, plus here I have B root AB. So this way I can write like this. I hope I can understand this. Okay, fine. Yes. Yeah, okay, fine, all right. And what next I'm going to do is, I'm going to do another simplification process. Okay, what I'm going to do is, A plus numerator, again I'm going to keep it as it is, root AB plus B. Okay, fine. Yes, divided by. Here denominator I'm going to do a small adjustment. Okay, this is A root AB plus this 2 I'm going to write as 2 into, here I have AB, right? This AB I will write as root AB into root AB. We can write like this, right? Yes, because AB is nothing but root AB into root AB. Correct? Yes, is it or not? When you multiply the root value of twice with itself, you will happen to get the same value without the root. Okay, so plus B root AB, this is what you will have. And once again, the last step what I am going to do is, again I am going to keep the numerator as it is, A plus 2 root AB plus B divided by, now this time I can see root AB, root AB, root AB in all these terms in the denominator. I will take that one root AB as a common factor outside. So what I will have inside, carefully see, you will have inside as A, because here you remove this root AB outside, you will have only A here, A plus, here you will have 2 root AB. So 1 root AB you are removing it out, so you have root of 2 root AB plus, here you have what? 1 root AB, here you have, this will be taken out, so you will have B here. So that means these are the terms will be left with. So that means if you clearly see, here we have the term which is exactly what you have in the numerator term. You can now cut these two terms. So you will be left with only 1 by root AB, which is nothing but 1 by what? What is actually root AB? Root AB is what is actually G, correct? Yes. So 1 by G is what finally we are getting, and that's nothing but your right hand side. Okay, RHS. Finish, and this gives the proof for your question number 8. Okay, so yes, I think now we are clear with the proof for question number 8. Yes, okay, so a simple adjustment only. Okay, simple adjustment. We have to know that G is equal to root AB. Substitute it, do it carefully, you have to do it, and then you will be able to simplify and then get the answer as 1 by G. That will be equal to your right hand side. Okay, yes, I hope you are clear with this proof. So this is going to be the proof for your question number 8. Now we are with the question number 9, and here this is going to be the last question of this exercise. Yeah, let us see this question. Find the minimum value of 4 power x plus 4 power 1 minus x. This is going to be the question where x belongs to a real number. Okay, x is going to be a real number in the sense what will be the minimum value of this given expression. This is the question. So the question appears to be out of this concept, but still it is going to be something relevant to this concept only. Okay, yes, so this question follows from a very simple idea about the relationship between AM and GM of two numbers. Okay, so at the beginning itself we saw something, right? What is it we saw here? We saw about AM and GM. What is the relation between AM and GM? Always arithmetic mean of two numbers will be always greater than or equal to, it will be greater than or equal to geometric mean. Okay, always this arithmetic mean will be either greater than geometric mean or it will be equal to geometric mean. It can never be less than geometric mean. We saw the reason there. Okay, yes, how it works, everything we saw the introduction part itself. Okay, so there we saw the reason. So we are going to use this concept only, this result only, in order to get the answer for our given question. Okay, yes, fine. Yeah, okay. So now what we are going to do is we are going to treat these two values to be A and B. Fine. Okay, all right. So let's take A is equal to 4 power x, and we'll take B is equal to 4 power 1 minus x. All right. Okay. So this is A and this is B. Now let us come out with what is the AM, arithmetic mean of A and B. Okay. What is AM of A and B? AM of A and B will be nothing but what? AM. We know the value of AM, right? AM is going to be what? We will have to take the addition. Okay, so 4 power x plus 4 power 1 minus x divided by 2. This is going to be the AM. Yes, all right. Same way, let us see what is the GM of the same two values A and B. Okay, what about the GM of A and B? GM also we know what we have to do for GM. GM is nothing but square root of, we will have to multiply these two numbers, that is 4 power x multiplied by 4 power 1 minus x. This is what we have to do. Correct? Okay. So now I can very well use this relation now. Yes, okay. Shall we use it now? Okay. When you come to use this relation, okay, I'll just separate it. Okay, so that this won't confuse along with your solution. This is just a result to remind it. I have written there. Okay. Yeah, coming here. What happens is now we will have these two A and B values. We got the AM as well as GM, right? Now let us use that relation. So according to that relation, what happens is 4 power x plus 4 power 1 minus x whole divided by 2, that is this AM, will always be greater than or equal to this GM, which is 4 power x multiplied by 4 power 1 minus x. Correct? Yeah, okay, fine. Yeah, let's continue. Now what happens is, we will have the left hand side as it is. Okay, 4 power x plus 4 power 1 minus x whole divided by 2 is greater than or equal to. Now come to this one. This expression can be simplified as what? This can be simplified as root of, you can multiply these two terms, right? This is like multiplication, right? So 4 power x multiplied by 4 power 1 minus x will be nothing but 4 power. When you have same bases multiplied, we can add the powers, right? When you add the powers, what happens? X plus 1 minus x. This is what you will get. Correct? Yeah, fine. So I'm just adding the powers. X plus 1 minus x. That's what I'm adding. Okay, let me continue it here. Okay, I'll continue. Yeah, copy the same here. So you will have 4 power x plus 4 power 1 minus x whole divided by 2. The left hand side I'm not disturbing. I'm having it as it is. This is greater than or equal to. Come to the right hand side. Right hand side, what do you have now? Root of, you have 4 power x plus 1 minus x. This can be simplified as simply 4 power 1. So that means you have root of 4 power 1, which is nothing but what? Simply root of 4 power 1. This is going to be what? So you will have root 4 power x plus 4 power 1 minus x whole divided by 2. This is greater than or equal to. This is simply 2. Because root 4 is going to be 2 only, right? That's why. Okay. And that means 4 power x plus 4 power 1 minus x is always greater than or equal to. This 2 I'm going to take there. Okay. This is still an inequality, but this is a constant term only, right? I can just get this term to the other side. That is possible. So 2 into 2. When you multiply 2 2s, sir, it will become 4. So that means what is the meaning? That means definitely what you cancel. The thing what we can tell now is always the value of 4 power x plus 4 power 1 minus x will always be either greater than 4 or equal to 4. It can never be less than 4. This is what this is coming to say. Okay, this expression, all it comes to say is the value of 4 power x plus 4 power 1 minus x is what? This is always greater than 4 or it will be equal to 4. That means the meaning is the expression's value will be always at least equal to 4. It will be at least 4. This is what it comes to say. Okay, at least in the sense, what is the meaning? Yes. So it can be what? At least in the sense like this can be what? This can be the what? So this will be the least possible value. Okay, it will be at least this or it will be more than this. Okay, it will be either 4 or it will be more than 4. That is the meaning, right? It can take the value 4 or it can be more than 4, but it can never go below that 4. That is the meaning. So that means the minimum possible value it can reach itself is this 4 only. Okay, yes, fine. So at least 4 is means, so it means the minimum. Okay. Yes friends, I hope you are clear with the method and the concept, everything we used here to solve the problems, and also are clear with the basic concepts that we saw for this exercise. Everything is clear to you. And yes, if at all you feel that this session to be useful, please give a like, and if you feel this session to be useful for any of your friends, please do share this video to your friends also. And again, we'll catch up in the next session with some other exercise solution problems. See you soon there. Thank you so much.